Hello students, in our first lecture, we are going to concentrate on basic chemical principles. And in these basic chemical principles, you must know the atomic weight of first 20 elements. So just I share you the first 20 atomic elements and their corresponding atomic weight. If you see the atomic weight is in fractional nature. That means 1.00, 4.00, 6.94 like that. But for calculation of molecular weight, you can consider only the integer part of it or full number of that particular atomic weight. For example, here you see that your first atomic weight, first element in our atomic series is hydrogen. First atomic element is hydrogen. And that hydrogen atomic weight is 1, that is 1.01. So here you can write down it is 1. Second element helium, that atomic weight is 4. Third element actual atomic weight is 6.94, but just for calculation purpose you can take it as a 7. Okay, so like this you can have fourth element beryllium, atomic weight 9, then boron, fifth one, then carbon you can take atomic weight 12, then we have nitrogen, atomic weight 14, then we have oxygen, atomic weight 16, then we have 19, then we have neon 20, then you go sodium, it is 23, magnesium, it is 24, then we have aluminium, it is 27, then we have silicon, that is 28, then phosphorus 31, sulfur 32, chlorine 35.5, then argon you take it as a 40, potassium you can take it as a 39, calcium you take it as 40. Okay, so these first 20 elements start from hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphor, sulfur, chlorine, argon, potassium and calcium. And this atomic weight is the weight of proton, weight of neutron and weight of electron. Okay, so that depend upon how many protons in the element, how many neutrons in that atom and how many electrons. And you know that number of protons is equal to number of electrons. Okay, and addition of weight that gives atomic weight, of that particular element. For example, if you consider oxygen, so in case of oxygen there are 8 protons at its atomic number, 8 protons, there will be 8 neutrons and electrons also 8. And addition of this weight 8, that gives the total atomic weight of oxygen, that is 60. Okay, so weight of proton plus weight of neutron plus weight of electron. Now this weight of electrons is very less. It's very less comparatively, and therefore you can neglect. This weight of electrons, and from this you can have that weight of proton plus weight of neutrons, that is equal to atomic weight, and that is coming. In case of oxygen it is coming 60. Okay. Now come to this lithium. That it is 6.94, you can take it as a 7. Okay. Sulfur it is 32 because that contains 16 proton and 16 neutron. So generally this number of protons and number of neutrons are same. General, I am not saying that always. But in case of some element, the number of neutron changes atom to atoms, and you call this as isotopes. That means number of neutrons are different. For example, in case of hydrogen, you may have one neutron in that hydrogen, or you may not have that neutron in the hydrogen. So like this atomic weight slightly varies atom to atom when number of neutrons are different. When number of neutrons are different. For example, in case of chlorine, I just here with a chlorine. See why it is 35.5? Because in chlorine, number of protons 100% 70. But when you think about the number of neutron, this neutron number varies. It may be 17, it may be 18. Okay? So like this number of neutron that is going to vary. Okay? So that number of neutrons that is going to vary in case of this chlorine, or it may be 19 also. So the number of neutrons vary in case of this chlorine, and therefore this atomic weight is taken on average basis, that is 35.5. That is taking 35.5 because here number of neutrons that is going to change. The number of neutron changes here in case of chlorine atom, and therefore that we get average 35.5. Okay? So like this, you must have the knowledge of first 20 elements atomic weight, and then only with the help of this atomic weight you can find out molecular weight of the compound. Now step by step we will find out some of the molecular weight of the compound, and for this purpose I have just taken certain chemical compound. First one is carbon tetrachloride, then chloroform, butadiene, chloroacetic acid, chloromethane, formaldehyde, ethylene glycol, all that. Okay, so first I explain how to calculate molecular weight of the compound. So you just first will a compound. Here we have carbon tetrachloride. So carbon tetrachloride means how many carbon? There is one carbon and 4 chlorine. So we have one carbon and we have 4 chlorine atoms. Okay, and we know that carbon atomic weight 12, and chlorine atomic weight 35.5, and therefore you get the molecular weight of this carbon tetrachloride as 154. That is 12 plus 4 in bracket 35.5. So you get it is 154. Okay. So similarly you please try to find out the molecular weight of other compound that is given here. For example, here chloroform, that is 1 carbon plus 1 hydrogen plus 3 chlorine atom. So 1 carbon, that atomic weight is 12, 1 hydrogen, so atomic weight 1, and as there are 3 chlorine, so 3 in bracket 35.5. Okay, so you please operate calculator, how much coming, you just write down that. Like this, you as a homework, you please find out the molecular weight of these all compounds, and you must know that which compound, what is its chemical formula. For example, propanol is one of the alcohol. Propanol, what will be the molecular weight of the compound? CH3, CH2, CH2OH. Like this, you should be able to give the chemical formulas of different compound. One of that compound, let's sugar, that is sucrose. Sucrose means, what is the molecular formula of sucrose? Molecular formula of sucrose is C12H22O11. So that means 12 carbon, 22 hydrogen atom and 11 oxygen atom, and with this you will get molecular weight of sucrose, that is sugar. So please operate calculator and find out this value. Please operate calculator. So 12 carbon means how much it will be? 144. 12 hydrogen means that will be 12. 22, that will be 22. 12 carbon, 12 into 12, 144. 20 hydrogen atoms, so 20 into 1, that is 22. 22 into 1, 22. And there are 16 oxygen atoms. So 11 into 16, oxygen atomic weight 16. So 11 into 16, how much it is coming? It is coming 176. And therefore, sucrose, that is sugar molecular weight, how much it is coming? Just go for addition. It is coming 342. It is coming 342. In short, today we study that molecular weight of sugar, that is sucrose, is 342. Like this, you please operate calculator, just go for the addition of atomic weights of the element in the chemical formula and you will get atomic weight. You will get atomic weight. So now we will use this atomic weight in the calculation of molecular weight and then give to the composition of mixture. Now what happens, number of times in industry you are not getting all pure compound. You get compound as a mixture. Just like medicine, in medicine also there different composition is there, paracetamol is there, azithromycin is there. So different compounds are there in one medicine or different chemical formulas are in one mixture. And then the composition of this mixture, can be given by these different methods. So which are these methods? So first method is weight percent. It may be given in mole percent, it may be given in volume percent, or it may be given as molarity, normality, molality, like this. Okay? So what is the weight percent? So here we have this formula for weight percent. Suppose we have this mixture. We have mixture of three compounds, A, B, C. So we have mixture that contain A, that contain B, and that contain C, different chemical formula. Then we have weight percent of A means what? Weight of A divided by total weight into 100. Okay? Similarly, you can calculate weight percent of B, that will be weight of B divided by total weight into 100. Similarly, weight of C, that will be weight of C upon total weight into 100. Like this, and all weight percent, that will be 100. All weight percent, that will be 100. Another method, that is called mole percent. And mole percent means what? Mole percent of A means moles of A divided by total moles into 100. Similarly, for volume percent, what you can write down? Volume of A divided by total volume into 100. So like this, you can find out the percentage composition of different compound in the mixture. And percentage divided by 100. And percentage divided by 100, that gives mole fraction. So when you divide any percentage divided by 100, you get fraction. So you please note that percentage divided by 100, that is called fraction. Percentage divided by 100, that is called fraction. And these are different methods by which we can express composition of mixture. Okay. So now one of the next term, that is what is mole. Mole means what? Okay. So this mole, it is an amount of substance containing this much molecule, 6.02. Just you see that how much this bigger number is there, that is 10 raised to 23 is there. So it is an amount of substance containing 6.02 into 10 raised to 23 molecules. That means when this much number of molecules come together, then we call this as 1 mole. So okay, so suppose this is small bottle, very small bottle, that contain number of molecules 6.02 into 10 raised to 23 molecules. then we can call this as 1 gram mole. Then it is called, we can call this as a 1 gram mole or 1 mole. So any substance, when you take this much number of molecules, then it is called 1 gram mole. For example, in case of water, when you take this much molecules of water, then it is called 1 gram mole of water, and that is equal to 18 gram. Because water molecular weight 18. Water means what? 2 hydrogen and 1 oxygen. 2 hydrogen, atomic weight 1, so 2 into 1, 2. Oxygen atomic weight 16, so you get 18. So when 18 grams of water is there, then it is called 1 gram mole of water. When 18 gram of water, that is called 1 gram mole water, and that is nothing but this much number of molecules of water. This much number of molecules of water. Okay. So here now we have this one question. What is the mass of 1 gram water molecule in grams? Okay. So when this much gram mole of water, this much molecule. That means 18 gram, this much molecule. What is the mass of 1 gram, 1 water molecule in gram? Mass of 1 water molecule. So what will be that? This much molecule, this much gram. So where 1 molecule will be what? How much mass? See here, 1.02 into 10 raised to 23 molecules. When this much molecules come together, corresponding mass is 18 gram. Then what will be mass of 1 molecule? So mass of 1 molecule will be 18 divided by 6.02 into 10 raised to 23. So whatever value of this number, this will be mass of 1 molecule of water. This will be mass of 1 molecule of water. Okay, any doubt in this? Now go to next question here. Now we'll solve this question here. How many hydrogen molecules are there in 0.25 moles of hydrogen? 0.25 moles of hydrogen. How many hydrogen molecules? So first, what is molecular weight of hydrogen? H2. Hydrogen gas is there, H2. So see how you solve. 1 moles of water. 1 moles of hydrogen means how many molecules? 1 moles of hydrogen means how many molecules? 1.02 into 10 raised to 23 molecules. Molecules of hydrogen. Right? When 1 moles of hydrogen, I already explained you, 1 moles of hydrogen, that is nothing but this much molecules. 1 mole of water means this much number of water molecules. 1 mole of sulfur dioxide means this much molecules of sulfur dioxide. So here they are mentioned 0.25 moles of hydrogen there. If there is 0.25 moles of hydrogen, that equal to how many molecules? That will be how many molecules? That will be 1.02 into 10 raised to 23. See here, 1 mole this much. 0.25 moles of hydrogen means how many molecules? So you have to just take, suppose you take this value as y. Suppose this you take this y value will be that Tirkas Gunakar. Okay, cross multiplication, y into 1 will be this into this. And so that you will get, y value you will get as into 0.25. So when this much number of molecules will be in 0.25 moles of hydrogen. 0.25 moles of hydrogen. If you are not getting, again just I solve. Okay. We have we have here 0.25 moles of hydrogen. Let that is equal to Y molecules. Let that is equal to Y molecules. Then you go for cross multiplication. What is cross multiplication? 1 into Y. That is equal to 6.02 into 10 raised to 23 molecules. Okay? 1 into Y into 0.25. Tirkas Gunakar. Probably you have studied that in mathematics. So 1 into Y, that means 1 moles of hydrogen into Y, that is equal to 6.025 into 10 raised to 23 molecules into 0.25. And therefore you will get Y, that will be, Y will be this value. That this much number of molecules is nothing but 0.25 moles of hydrogen. Okay, so such examples will be asked as MCQ question for 1 mark. As MCQ questions for 1 mark. Now step by step we go for next one. So just here we have one solve problem. What is the weight percent of glucose in a solution made by dissolving 4.6 gram of glucose in 145 gram of water? Okay, so what they have given in this problem? How much amount of water is there? 145.2 gram of water. How many gram of glucose is there? 4.6 gram of glucose is there. So total weight of the solution will be how much? So this is the amount of glucose plus this is the amount of water. And therefore you get total weight is 149.8. And we know that when you want to calculate weight percentage, what is the formula? Weight percent of glucose, that will be weight of glucose. Weight of glucose how much here? Weight of glucose is 4.6 gram. Okay, weight of glucose 4.6 gram and weight of total weight is how much here? 149.8. Total weight is this much. So when you want to find out weight of glucose, weight percent of glucose divided by total weight into 100, and you get here 3.1%. You get here 3.1%. Similarly, you can calculate weight percent of water. So weight percent of water, that will be equal to what? Weight of water. Weight of water how much? 145.2 divided by total weight is how much? 149.8 into 100. Okay, so whatever this is coming, that will be weight percent of water. So please operate calculator and give me value. I also operating calculator and checking this value. Okay, it is coming 96.92. It is coming 96.92. Okay, and you can see that here, whenever there are two compounds, the percentage addition of these two compounds dash must equal to 100. So this 3.1%, this 96.92%, so that you will get percentage addition, that will be 100. Percentage addition, that will be 100. Like this, you have to find out the weight percent of different compounds when composition is given. Okay. So let me have one more another questions. How would you prepare 400 gram of 2.5% solution of sodium chloride? So they have mentioned that 2.5% solution of sodium chloride. So that is weight percent. They have mentioned it is weight percent. They have to mention that this 2.5%, that is weight percent of sodium in solution. 2.5 weight percent of the sodium chloride in solution. Okay. See here. So how to solve this? weight percent is 2.55, weight percent 2.5% sodium chloride. How you treated 400 gram. Okay, so when you take suppose 100 gram, when you take 100 gram solution, so 100 gram solution, here I write down solution, here I write down salt required or NaCl required. As they have mentioned 2.5%, that means in 100 gram of solution NaCl is 2.5 gram. We want how many gram of solution? We want 100 gram of solution. So prepare 100 gram of solution. How much NaCl will require? Prepare 400 gram solution. How much NaCl required? Let us suppose Y. Okay? Then you have to take cross multiplication. And what is the cross multiplication? That 100 into Y, that is equal to 2.5 into 400. 400 into 2.100 into Y. Okay? And from this you will get Y, that will be 2.5 into 400 divided by 100. And that is coming, how much it is coming? That is coming 10 gram. That means 10 gram of NaCl required to prepare 400 gram solution. That means water quantity will be how much? 400 minus water quantity, 400 minus salt quantity, you get water. So total weight 400, in that salt 10 gram. So 400 minus 10, that means water will be 390. That means to prepare this solution, you have to add 390 gram water and you have to add 10 gram salt, so that total weight 400, and that contain how much percentage of sodium chloride? 2.5% of solution of sodium chloride. So that this way, if you know the composition, then you can find out the amount of component required or amount of component used. So here you have to, when you want to prepare 2.5% NaCl, you have to take 390 gram water in the beaker, and in this beaker you add 10 gram NaCl. So when you add 10 gram NaCl in that, you stir this so that you will get 2.5% NaCl solution. NaCl solution, that is in the water. Okay, so see here, the composition 2.5, that is given, but how much amount of NaCl required, how much amount of water required, you can calculate these values. Only when you know these formulas. Which formulas? How to find out the composition of mixture. You know these formulas. You know the molecular weight of the compounds, atomic weight of the compound. Then only you can go for the different composition analysis. Okay. So with this, just I stop this our point, atomic weight calculation, molecular weight calculation, and how to express composition of different compound in 1 unit, weight percent, mole percent. You can also go for volume percent when density is given. Okay. So with this, just I stop here. Now we'll solve some problem based upon this. Thank you.